Hello students, welcome to the fifth video of straight lines. In this video we will learn about symmetric form and parametric equations of straight lines. Okay, now what is symmetric form? See, suppose this is our x-axis and this is our y-axis. Okay, we need to find the equation of this straight line, and this straight line is making some angle theta with the positive direction of x-axis measured anti-clockwise. Okay, and this line is passing through, let us say, x1 comma y1. Okay, what do we have? We have a line which is passing through x1 comma y1, and the straight line is making an angle theta with the positive direction of x-axis measured anti-clockwise. Okay, we know how to find the equation of this straight line. Okay, using point slope form, y minus y1 is equal to m into x minus x1. We have learned in one of our previous videos. Okay, using this theta we can find the value of m, that is slope, right? Tan theta is equal to m, right? And we have x1 y1. If we substitute the values of m and x1 y1 in this, we will get the equation of this straight line. This is point slope form. Why is it called as point slope form? We have one point and we have a slope. Okay, that's why it is called as point slope form. But using this point slope form, we can write symmetric form of the equation, symmetric form of this equation. Okay, now what is that? See, derivation is very easy. Y minus y1 is equal to m. M is what? Tan theta. Tan theta x minus x1. But we know from trigonometry tan is equal to sine by cos, right? So this is sine theta divided by cos theta x minus x1, and on LHS y minus y1. Okay, if you cross multiply, see, sine goes this side, right? This is in the numerator, this comes to the denominator. So this is y minus y1 divided by sine theta is equal to, what do we have here? X minus x1 in the numerator divided by cos theta in the denominator. This is symmetric form. Okay, symmetric form of a straight line. See, we can write this as x minus x1 divided by cos theta is equal to y minus y1 divided by sine theta, or x minus x1 is to cos theta. Division is to only, right? Is equal to y minus y1 is to sine theta. This is the symmetric form. Alright. X minus x1 divided by cos theta is equal to y minus y1 divided by sine theta. Okay. And theta is the angle made by this line with respect to the positive direction of x-axis. With respect to x-axis, right? Okay. Now, what is parametric equations? What is parametric equations? Let me just rub this part and explain you what parametric equation is. Okay, this is symmetric form, right? Okay, now see here, first let us understand the concept behind this parametric equations. Students will be very confusing. Students will get confused a lot in this. Okay, suppose we have a straight line, okay, and this straight line is making some angle with x-axis. Let us say it is theta. Okay, we need to find, see, let us say we have a point x, x1, y1 on this straight line, and there is one more point, okay, which is some r units away. R is a parameter, okay, which is r units away from this point, and this point is lying on the same straight line. Okay, see here, what do we have? We have a straight line which is making angle theta with x-axis. Let us say this is x-axis, this is y-axis. Okay, this line is making angle theta with x-axis, and there is a point x1, y1, okay, which is on this straight line. there is one more point, there will be one more point on this straight line. Let us say this point is r units away from this point. Okay, from here to here the distance is r units. Okay, then the coordinates of these points are given by x1 plus r cos theta, comma y1 plus r sin theta. Okay, x1 plus r cos theta, y1 plus r sin theta. Alright. Now, see, this point is r units away, right? Do you think we'll have only one point which is r units away from this point on the same straight line? We will have one more point. One more point will be below this point. See, let us say we have a point here. This will also be r units away. Like for example, if we say this is 4 units away, from here to here the distance is 4, we'll have one more point which is 4 units away here also, at this side also, isn't it? So if you are taking a point which is this side, we treat it as plus 4, we take plus 4. If we take here, it is plus r minus r. Okay, so this point we write it as x1 minus r cos theta, comma y1 minus r sin theta. Okay, so from this point we will have 2 points which are r units away from this point. Okay, we'll have 2 points which are r units away from this point, and those points are x1 plus r cos theta, y1 plus r sin theta, x1 minus r cos theta, comma y1 minus r sin theta. Okay, this are called as, see, x1 plus minus r cos theta, comma y1 plus minus r sin theta. We combined these 2 points and we wrote it like this. This is called as parametric equations of straight line. Okay, and this r will vary. R can be here very close to this point, here, here, here. It can be anywhere, right? Here, here, here. So it varies. Okay, hence it's a parameter. It will change its value, right? It is a parameter. Hence this form is called as parametric equations of straight lines. Okay, I hope this is clear. Understand the concept clearly. I'll explain it again. See, suppose we have a point, let us say x1, y1, okay, and on the same straight line, r units away from this line, there will be one more coordinated, one more point, and it is x1 plus r cos theta, comma y1 plus r sin theta, and we'll have one more point which is below this point, and the coordinates of that point will be x1 minus r cos theta, y1 minus r sin theta. Okay, all right, I hope this is clear. We'll do few problems on symmetric form as well as on parametric equations of straight line form. Okay, okay, I actually forgot to derive the parametric equations of straight line. This is the symmetric form, right? So from symmetric form we will derive parametric form. See, this is x minus x1 divided by cos theta. Okay, x minus x1 divided by cos theta, let it be a parameter r. Okay, now y minus y1 divided by sin theta, let it be r. Why are we taking both equal? Because these two are equal. x1 minus x minus x1 by cos is equal to y minus y1 by sin. If you take this as r, this will also be equal to r. Okay, now if you cross multiply, x minus x1 is equal to r cos theta. Okay, now here what do we have? Y minus y1 is equal to r sin theta will come here. Okay, if you send x1 this side, see, x will be equal to x1 plus r cos theta, and here y will be equal to y1 plus r sin theta. Okay, but this parameter r will be the distance. Okay, why will it be the distance? Let us find out. See, let us take this two. Okay, let this be equation 1, let this be equation 2. Let us square both sides and add. First one, squaring on both sides, whole square is equal to r square cos square theta. Okay. Second one, square on both sides. I'll write below. Y minus y1 whole square is equal to square here also r square sin square theta. If you add this, this will be x minus x1 whole square plus y minus y1 whole square is equal to r square cos square theta plus r square sin square theta. Okay, I hope this is clear. Now can we take r square common here? Yes. So r square, this will be cos square theta plus sin square theta. This cos square theta sin square theta is equal to 1, right? So r square into 1 will be r square. Okay, so here we'll have x minus x1 whole square plus y minus y1 whole square, and this square goes on the other side, becomes root. Isn't it familiar? Okay, this is distance formula, distance between the points x comma y and x1 comma y1. Okay, so r is what? It is distance. Okay, r is distance, so that's why we take it as mod r. If you remove the mod, we will have plus r and minus r. Okay, I hope this is clear. So r is actually the distance between these 2 points. Okay, first let me just check whether this is visible in the video or not. Yes, this is visible, right? Some part is cutting here, but I think you can understand that. Okay, so that was about parametric equations of straight lines. This parametric equations of straight lines is derived from symmetric form, and symmetric form in turn is derived from point slope form. Okay, alright, let me just pause the video and we'll do few problems now. Okay, let us solve this example. Okay, now we have a question here. Write parametric equations of straight lines passing through 3, 2. Okay, passing through 3, 2 and making an angle 135 degrees with positive direction of x-axis in the positive direction. Okay, what do we mean by this? See, let us say this is our x-axis and this is our y-axis. Okay, we need to find the parametric equations. Alright, just now we have studied what are parametric equations. x1 plus minus r cos theta, y1 plus minus r sin theta, right? And what is theta? 135. So the line will be like this. This is 135 degrees. Okay, this line is making 135 degrees with the positive direction of x-axis. Okay, let us say we have a point 3, 2 here. Alright, now we need to find another point which is r units away from this point on the same straight line. Let us say this is one point and we'll have one more point, right? Let us say this is A and we'll have one more point, let us say B here. But we need to find that the parametric equations in the positive direction. See, this is the positive direction above 1. Okay, this is positive because here we'll take as minus r and here we'll take it as plus r, right? Okay, so this is the positive. We need to find this one. Okay, so we'll remove this minus sign. x1 y1 here is 3, 2. So here we have 3 plus r. R value is not given. We'll write r only. Cos 135 degrees and y1 is equal to 2 plus r sin 135. Okay. So 3 plus r cos 135, 2 plus r sin 135. Let us find the values of cos 135. Cos 135, we can directly write the values, or see, cos 90 plus 45, right? Cos 90 plus 45 is sin 45 and 135 will lie in the second quadrant. And in the second quadrant, cos value is negative. So this is minus. So minus 1 by root 2 will come here. So this is 3 plus r minus 1 by root 2. Okay. Comma 2 plus r. Okay. Now sin 135 we can write it as sin 90 plus 45. Sin 90 plus 45 is equal to cos 45, and 135 will lie in the second quadrant and sign is positive. Okay, so this is plus 1 by root 2. So this is 1 by root 2. Okay, so this is 3 minus r by root 2. Okay, what is this? This is x value. 3, x value is 3 minus r by root 2, and y value is 2 plus r by root 2. So these are the parametric equations of the straight lines. Okay, parametric form will look like that. Alright, I hope this problem is clear. Let us do the second problem. A straight line passing through A 1 comma minus 2 makes an angle tan inverse 4 by 3. Okay, theta is how much given? Tan inverse 4 by 3. So tan goes on the other side, it will become tan theta is equal to 4 by 3. Okay, alright, with positive direction of x-axis in the anti-clockwise sense. Okay, in the anti-clockwise direction, find the points on the straight line whose distance from A is 5. Okay, now see here, we have a straight line. Let us say this is point A and it is 1 comma minus 2. We need to find points which are 5 units away, from this point A. We'll have two such points, isn't it? We'll have one, this point, let us say this is x, and we'll have one such point here, y. Okay, this will also be 5 units away. We'll have 2 points which are 5 units away. One will be this side and one will be this side. For this side we'll take it as positive, for this side we'll take it as negative. Okay, now these are actually r values. So r can be plus 5 and r minus 5. Okay, now see, what is this form? We have a point and at a distance of r we need to find the coordinate points. We need to find the coordinates of the points. Okay, we can use this parametric form, isn't it? So it is x1 plus minus r cos theta, y1 plus minus r sin theta. Okay, alright. See, we'll write r value here. We are writing plus minus together, right? So here x1, y1 is 1 comma minus 2. Okay, what about cos and sin? How should we find cos and sin? Tan is 4 by 3 given. Okay, tan theta is 4 by 3. Okay, so if we draw a right angle triangle, if theta is here, okay, this one will be the opposite side, this is the adjacent side, and this is hypotenuse side. So tan is opposite divided by adjacent, right? So this is 4 and this is 3. Opposite is 4, adjacent is 3. So this hypotenuse will be equal to 5. Use Pythagoras theorem and find the value of hypotenuse. It will be equal to 5. Okay. Now we need to find cos. What is cos? Cos is adjacent divided by hypotenuse. So this will be 3 by 5. What is sin? Opposite divided by hypotenuse. Sin will be 4 divided by 5. So we'll substitute these values here. Okay, what is x1? x1 is 1 plus minus r is 5 given. 5 cos theta. Cos is 3 by 5. Okay. y1 is minus 2 plus minus r. r is 5 sin theta. What is sin? 4 by 5. This is 4 by 5. 5 here will get cancelled. We'll have 1 plus minus 3 and minus 2 plus minus 4. Okay. We'll write plus 1 minus 2 plus 4 and we'll write minus. Okay. So this is 4 comma 2 minus 2 comma minus 6. Okay. These are the 2 points. So here x will be 4 comma 2 and y is minus 2 comma minus 6. Alright. I hope this is clear. We'll solve another problem now. Okay. We have an interesting question here. A straight line parallel to the line y is equal to root 3x passes through 2 comma 3. Q2 comma 3. So there is a line. Okay. Equation of this line is y is equal to root 3x. Okay. And there is a straight line which is parallel to this line and passing through 2 comma 3. So we have a parallel line to this line. We don't know the equation of that line. Okay. but we know that this line is parallel to this line and it is passing through q 2 comma 3. Let us say that point q is here and cuts the line 2x plus 4y minus 27 is equal to 0 at p, which means this line is passing through 2 comma 3 and it is cutting this line. Okay, equation of this line is given, it is 2x plus 4y minus 27 is equal to 0 at p. Okay, this is cutting at p. We should find the length of pq. Okay, how should we find the length of PQ? See, this is not perpendicular. Okay, it need not be perpendicular. We don't know. Okay, how should we find the length of PQ? Okay, now see, y is equal to root 3x. Okay, what is the slope of this line? It is root 3. See, we know y is equal to mx plus c. Okay, this is slope intercept form and we have y is equal to root 3x plus c value is 0 here. Okay, which means what is the value of m? M is root 3. That is tan theta is root 3. Okay, tan theta is root 3. Alright, now if tan theta is root 3, what will be the value of theta? 60 degrees, because tan is root 3 at 60 degrees only, right? Okay, so this angle, this line is making 60 degrees with x-axis, which also means this line is also making 60 degrees with x-axis because these two lines are parallel to each other. Okay, alright, so let this distance be some r. Okay, let this distance be r and we know the angle that this line is making with x-axis and we have a point. So does it ring some bell? Okay, is it ringing some bell? See, this is let us say x comma y. Okay, we have a point x comma y. At a distance of r units, we need to find one point. Okay, what will be the coordinates of this point? x1 plus r cos theta, y1 plus r sin theta. Right, coordinates of this point will be x1 plus r cos theta, y1 plus r sin theta. Okay, and theta is the angle which is this line making with x-axis. This is our x-axis, right? We have a similar case here. Okay, we have theta 60 degrees that this line is making with x-axis, and we have a point 2 comma 3. We'll take this as x1 y1. All right, and we have distance r. We don't know the distance r, but can we find this point p? Yes. After finding this point p, we'll substitute this point p in this equation because this point is lying on this straight line. Okay, it should satisfy. Okay, that will be our approach. All right, so it's a very interesting question. Let me just rub this and explain you. Okay, we don't know the coordinates of this point. We are finding that in terms of r. Okay, what will be the coordinates of this point p? x1 plus r cos theta. Okay, y1 plus r sin theta. Alright, so what is x1? 2 plus we don't know what is r, cos 60. Okay, y1 is equal to 3, right? So this is 3 plus r sin 60. Okay, so these are the coordinates of point P. So this will be 2 plus r cos 60 is 1 by 2. So this will be r by 2. This is 3 plus r. This is root 3 by 2. This will be root 3 by 2. Now this point P is lying on the straight line 2x plus 4y minus 27 is equal to 0, right? Okay. Now if we substitute this, in place of x if we write 2 plus r by 2 and in place of y if we write 3 plus r root 3 by 2, it should satisfy this equation. Okay. From there we'll find the value of r. R is the distance between P and Q. We need to find that only, right? Length of PQ. Okay, that's how we'll get the value of r. Okay, so let us substitute 2x plus 4y minus 27 is equal to 0. Okay, so 2 in place of x, let us write 2 plus r by 2 plus 4 multiplied by, this is 3 plus r root 3 by 2 minus 27 is equal to 0. Okay, let us multiply 2 2s are 4 plus this is 2r by 2 plus 4 3s are 12 plus 4r root 3 by 2 minus 27 is equal to 0. This will get cancelled, this will get cancelled 2 times, right? So 4 plus r plus 12 plus 2r root 3 minus 27 is equal to 0. Did we write everything? 4 r 12, yes. 4 and 12, 16. Okay. 4 and 12, 16. 16 minus 27 minus 11. So minus 11 is equal to 0. If you take r common from these two terms, r, this will be 1 plus 2 root 3. Okay. Or we can write r 2 root 3 plus 1 is equal to 11. This 11 goes on the other side. We should find the value of r. So r is 11 divided by 2 root 3 plus 1. Okay. We can rationalize and write it. Rationalizing factor will be 2 root 3 minus 1. Okay. So 2 root 3 minus 1. So this is equal to 11 multiplied by 2 root 3 minus 1 divided by, this is a plus b, a minus b. So a plus b, a minus b will be equal to a square minus b square. So this is 2 square 4, root 3 square will be 3 minus 1. So 12 minus 1, 11. So 11 will come here. This 11 will get cancelled. What is the value of r? It is 2 root 3 minus 1. Okay. Of course, see, this can be plus minus, right? So let us write this in mod. So 2 root 3 minus 1 is the distance between the points P and Q. The length of PQ is 2 root 3 minus 1. Okay, we have a problem here. Find equation of straight line in symmetric form. Okay, what is symmetric form? X minus x1 divided by cos theta is equal to y minus y1 divided by sin theta. Okay. If we write the equation in this form, that form is called as symmetric form. Given the slope and the point. Okay, slope is given and the point is also given. Okay. See, x1, y1 is given to us and we have slope. Okay. See, tan theta is root 3, which means theta is equal to 60 degrees, right? So we can write cos 60 and sin 60 here. Okay, let us do the first problem. X minus x1. See, this is x1, this is y1. Okay, x minus x1, that is 2 divided by cos 60 is equal to y minus y1, 3 divided by sin 60. That's all. This is the symmetric form of the equation. Symmetric form of the straight line. Okay. We need not write the values of cos 60 and sin 60 in this form. Okay. Of course, this 60 we can write it as pi by 3. Cos 60 is cos pi by 3, right? You can write it as pi by 3 here, pi by 3 here, or you can just write cos 60 sin 60. Okay. Alright, so the first problem is done. Let us do the second bit. Here, tan theta is minus 1 by root 3. How should we find the value? And x1, y1 is minus 2, 0. Okay. Now see here. This is 0 degrees. This is 90 degrees. And this is 180 degrees. 270 degrees. And again 360 degrees here, right? Now see. We should check when is tan 1 by root 3 at 30 degrees, isn't it? Tan is 1 by root 3. See the magnitude of this 1 by root 3. Forget about the sign for a while. 1 by root 3. So when is tan 1 by root 3 at 30 degrees? So this is 1 by root 3. This is our angle 30 degrees. Okay. This is our angle 30 degrees. Okay, focus. See, we are doing trigonometry now. Okay, come out of straight lines, we are doing trigonometry. Now, see, if you place a mirror here, this line will exactly look like this right here, and this angle will also be 30 degrees. If this is 30, this will also be 30. Okay, now this will be minus 1 by root 3. See, this is plus 1 by root 3. and tan value will be negative in the second quadrant, right? So this will be minus 1 by root 3. Okay, alright. So we are given this value minus 1 by root 3 because we have minus here. So we should consider from here to here, the angle from here to here. So total 180, total is 180 and we need to subtract this 30 to get this angle, right? So 180 minus 30 is 150 degrees. So this is 150 degrees. So theta here is 150 degrees. I hope you understood. Okay. Let me just rub this. I think we'll use that in the third bit also. Anyways. Okay. Now theta is 150 degrees. So we need to substitute it here. X minus x1. x1 is how much? Minus 2. So minus of minus 2 will become plus 2. Cos 150 degrees is equal to y minus y1, 0 divided by sine 150 degrees. Okay, we can write this in terms of pi also. See, some students will get confused. Sir, how should we write this degrees in radians in pi? I'll give you a trick. See, let us say we need to write 150 in terms of pi. We don't know what will come here. Okay, pi by 3, pi by 4, 2 pi by 3, 5 pi by 3, n is something, right? So let us write it as n. So this will be 150 is equal to n. Pi is 180, right? So let us send this 180 on the other side. 150 divided by 180 will be equal to n. So 0, 0 will get cancelled. This is, see, 15 and 18. 15 and 18 will go in 5 table. So 5 and here it will be 6. So n is how much? 5 by 6. So here write 5 by 6. So 5 pi by 6 is 150. Okay, we can write this as cos 5 pi by 6 or sine 5 pi by 6. Alright, I hope you understood this problem. Let us do the third bit now. Okay, alright. Tan theta is minus 1. Okay. Now pause the video and tell me what will be the angle theta. See, we know, let us take the magnitude 1. It will be 1 at 45 degrees, right? And again exactly opposite here, it will be minus 1. Alright. So if this is 45, this will also be equal to 45. Okay. Now 180 minus 45. How much is 180 minus 45? 135 degrees. So this is 135 degrees. So theta will be equal to 135 degrees. Okay. Alright. Now, third bit, x minus, this is x1, this is y1. X minus x1 divided by cos 135 is equal to y minus y1, because y1 is also 1, divided by sine 135. This is the symmetric form. Okay. Now how should we write 135 in terms of pi? 135 is n, pi is 180. So this 180 goes here, we need to divide this, right? Okay. So divide using 5 table. How much do we have here? We'll have 180 divided by 5. 5 3 is a 15, 6 36. This is 36. Okay. And here we'll have 135 divided by 5. 5 2s are 10, 7s are 27. Okay. Yes, 27. And 27 and 36 will get cancelled using 3 table, right? So let us write 9 and here 12, and this is 3 and this is 4. So this is 3 pi by 4. Okay. 3 pi by 4. We can write cos 3 pi by 4 or sin 3 pi by 4 also. Okay. We'll do few more problems now. Okay. A straight line passing through A minus 2 comma 1 makes an angle 30 degrees with OX in the positive direction. OX is x-axis. Okay. So a straight line is passing through minus 2 comma 1 and it is making angle 30 degrees with the positive direction of x-axis. Find the points on the straight line whose distance from A is 4 units. Okay. See, this is our x-axis and this is our y-axis. We have a straight line which is making angle 30 degrees with the positive direction of x-axis, and this line is, let us say, passing through minus 2 comma 1. Of course, see, minus 2 comma 1 will not lie in the first quadrant, but this is just a rough diagram. Okay, makes an angle 30 degrees with OK. Find the points on the straight line whose distance from A is 4 units. This is point A. Okay, we need to find the points. Okay, one point will be here, which is 4 units away, and we'll have one point here, okay, which is 4 units away. Let us say this point is B, this point is C. Okay, so we'll have 2 points whose distance from A will be 4 units, right? Okay, how should we find these points? Which concept can we apply? See the diagram. Parametric form, isn't it? Parametric form. So what is that? It is x1 plus minus r cos theta, y1 plus minus r sin theta. So these are the points, right? So let us write x1. This is x1, y1. So this is minus 2 plus minus r. R is 4 units away. So it is 4 cos theta, 30 degrees. Cos 30, and here y1. Y1 is how much? 1. Plus minus r is 4 sin 30. Let us substitute the values of cos 30 and sin 30. Minus 2 plus minus 4. This is root 3 by 2. Cos 30 is root 3 by 2. 1 plus minus 4 multiplied by sin 30 is 1 by 2. So this will get cancelled. So this will also get cancelled twice. So this is minus 2 plus minus 2 root 3 comma 1 plus minus 2. Okay. See, these are 2 points. Minus 2 plus 2 root 3 comma 1 plus 2 and minus 2 root 3 comma 1 minus 2. So this is minus 2 plus 2 root 3 comma 3. This is 1 point, and minus 2 root 3 comma minus 1. This is the next point. Okay. Let us say this is B and this is C point. We found B and C. Okay. These 2 points will be 4 units away from minus 2 comma 1. Okay. I hope you understood this question. Okay. We have a very interesting question here. Find the points on the line 3x minus 4y minus 1 is equal to 0, which are at a distance of 5 units from the point. Okay. We have a straight line, and the equation of this straight line is 3x minus 4y minus 1 is equal to 0. Okay. And we need to find the 2 points which lie on this straight line. Let us say one point is here and another point is here. Let us say this is some A and this is B. We need to find A and B. Okay. But these points are at a distance of 5 units from 3, 2. Okay. Let us say this is point X and this is 3, 2. This is 5 units and this is 5 units away. This A is 5 units away from 3, 2 and B is also 5 units away from 3, 2. Okay. And these 3 points are lying on the straight line. Okay. See, this is parametric form, isn't it? What is that parametric form? x1 plus minus r cos theta, y1 plus minus r sin theta. This will give us 2 values, A and B. Okay. x1, y1 we know it is 3, 2 in this case. R also we know, which is equal to 5. Okay. But what about theta? Angle is not given. Okay. But can we find angle? Can we find cos value and sin value from this equation? Yes, we can find. See, if we write this as 3x minus 4y minus 1 is equal to 0, if we write it as y is equal to mx plus c, if we write this given equation in this form, okay, coefficient of x here will be the slope, that is tan value. If we get tan value, we can get cos and sin value also, right? So let us write this equation in this form. So what do we have? We have 3x minus 1. I am sending 4y on the other side. Or we can write this as 4y is equal to 3x minus 1. 4 goes on the other side. It will divide like this, right? So we have y is equal to mx plus c. c is minus 1 by 4. m is 3 by 4. Okay? Alright. See, which is tan theta how much? 3 by 4. Slope is 3 by 4, which means tan theta is 3 by 4. Okay. If we have a right angle triangle, if theta is here, this will be the opposite side, this is adjacent side, and this is the hypotenuse side. Right? Tan theta formula, we know it is opposite divided by adjacent. So opposite divided by adjacent is 3 and 4 here. If we use Pythagoras theorem and find, the hypotenuse will be equal to 5. Remember this triangle, it's a very famous triangle, 3, 4, 5. Okay. So 5 is the hypotenuse. Can we get the value of cos theta now? Cos theta is adjacent by hypotenuse, so it will be 4 by 5. What is sin theta? Sin theta is opposite by hypotenuse, it will be 3 by 5. We'll substitute these values here now. Okay. Let us do this. x1. x1 is how much? 3 plus minus r. r is 5. Cos theta. Cos theta is 4 by 5. y1 is 2 plus minus r. r is 5. Sin theta 3 by 5. Okay. Now we'll simplify it. Let me just rub this part now. Okay. What do we have? See, 5 will get cancelled. 5 here will get cancelled. 3 plus minus 4. 2 plus minus 3. So it is 3 plus 4. 2 plus 3. Okay. And 3 minus 4. 2 minus 3. So this is 7 comma 5 and minus 1 comma minus 1. So these are the 2 points which lie on this straight line. 3x minus 4y minus 1 is equal to 0. How should we verify whether our answers are correct or not? We can substitute 7 comma y and minus 1 comma minus 1 in this equation, because these 2 points are lying on this line, right? So these 2 points should satisfy this. Okay. Or we can find the distance between these 2 points. Okay. Let us say b is minus 1 and this is 7 comma 5. Find the distance between these 2 points. Find distance between these 2 points. It should be equal to 5. Okay. I hope this question is clear. Okay. This is the final video, or this is the final problem, last problem in this video. What is the question? A straight line L is drawn through the point A 2 comma 1. Okay, let us say we have a point 2 comma 1. Okay, and we have a straight line. A straight line is drawn through this point. This point is A 2 comma 1, such that its point of intersection with the straight line x plus y is equal to 9. There is one more straight line. X plus y is equal to 9 is at a distance of 3 root 2 from A. See, there is one more straight line. What is the equation of this straight line? X plus y is equal to 9. Okay. This straight line is intersecting some point here. See, such that the point of intersection of this straight line is at a distance of 3 root 2. So this distance, this is point of intersection. Let us say this is point P. Okay. This point of intersection is how much distance away from point A? 3 root 2. So this is 3 root 2. From here to here, this is 3 root 2. Okay. Find the angle which the straight line L makes with the positive direction of x-axis. We should find what is the angle this line is making. What is the angle this line makes? This is line L. Okay. What concept can we use here? See, we have a point and distance r is given to us. Can we find this point? Of course, theta is not given. We will find this point in terms of theta only. Cos theta and sin theta will be there, and we will substitute this point on this straight line, because this point will lie on this straight line. Okay. Parametric form. We will use parametric form. See, x1 plus r cos theta and y1 plus r sin theta. Okay. x1, y1 is 2 comma 1 here. So this is 2. Okay. And this is 1. x1 is 2, y1 is 1. Plus r. r is how much? 3 root 2. So this is 3 root 2 cos theta. r is 3 root 2 sin theta. Coordinates of P. These are the coordinates of P. Okay. Now, point P is lying on x plus y is equal to 9, isn't it? So, if we substitute these values here, in place of x if you write this, and in place of y if you write this, and add, it should be equal to 9. Okay. Let us substitute these values. X plus y is equal to 9 in this. What is x? 2 plus 3 root 2 cos theta plus what is y? 1 plus 3 root 2 sin theta is equal to 9. From here we can get the value of theta. Let us see how. 2 plus 1 is 3. Okay. So that 3 comes this side, becomes minus, right? So it is 3 root 2 cos theta plus 3 root 2 sin theta is equal to 9 minus 3. 9 minus 3 will be equal to 6. Okay. If we divide both sides by 3, 3 and 3, 3 and 3, here 2 will come in. So this will give us root 2 cos theta plus root 2 sin theta is equal to 2. Okay. Can we take root 2 common from these two terms? Yes. If you take root 2 common, it will be cos plus sin is equal to 2. This root 2 comes this side. Okay. If you rationalize it, we have 2 root 2 divided by root 2 into root 2 is 2. Okay. So what do we have? We have cos plus sin is equal to root 2. Okay. We have cos plus sin is equal to root 2. Okay. Let me just rub this. Now simplify it. Cos plus sin is equal to root 2 is left. Okay. So cos theta plus sin theta is root 2 we got, right? See, if we square on both sides, what do we have? We'll have cos square theta sin square theta plus 2 cos theta sin theta is equal to, okay, we are squaring on both sides. A plus b expansion and root 2 into root 2 is 2. So cos plus sin is 1, right? This one will go on the other side. We'll have 2 cos theta sin theta is equal to 2 minus 1, 1. Okay, so we have 2 cos theta sin theta is equal to 1. This 2 goes on the other side, becomes 1 by 2. Okay, now which values will satisfy this equation? Cos theta multiplied by sin theta should give us 1 by 2. So I think 1 by root 2 multiplied by 1 by root 2 will give us 1 by 2, right? Which means cos theta should be 1 by root 2, sin theta should also be 1 by root 2. Okay, so when are this cos and sin 1 by root 2? At theta is equal to 45 degrees, right? At theta is equal to 45, cos 45 is 1 by root 2, sin 45 is also 1 by root 2. So the angle that this line is making with x-axis is how much? 45 degrees. Okay. See, there are many methods of finding theta value from here. Okay. This is one of the easiest methods, squaring. Okay. I hope you understood this video. See you in the next video.